Hi. In this lecture, we're going to talk about bringing models to data. Now, when I say data, what I mean is, you pull all sorts of numbers off the web, or maybe you've got, for your business or your home, you've got all this data out there and how much money you've spent each month or something like that. We're going to talk about how we can use models to understand that data. We're going to start simple and we're going to build up. So we're going to start with something that I call categorical models. Now, in a categorical model, what you do is you just sort of place all the different data in different boxes. So, for example, suppose you've got a bunch of data on how long people live, and you want to try and understand what allows someone to live a long and healthy life. Well, you might create one box of people who exercise and one box of people who don't exercise. And then what you can use, by looking at how much variation there is in each of those boxes and what the means are in those two boxes, you can figure out, does that distinction, make that categorization between exercising and not exercising, does that actually help understand all the variation in the data? After you do categorical models, we're going to move on to linear models. Now, when I make a distinction between a linear model and a line. So a line is just something that we plot, right? So we just have like, here's the y variable and here's the x variable, and we draw this line. In a linear model, what we assume is that we assume that this y variable depends on x, right? And so what this is this is some sort of relationship. So in this axis, x could literally be the amount of exercise you do, and y could be how long you live. And so what you have is this line is sort of saying that how long you live is a function of how much you exercise. So you're literally thinking of it that y is some function of x. Okay, so after we do linear models, and I explain what they mean, I'm going to have a short lecture sort of describing how we fit data to linear models. So if you got a bunch of data and then you want to construct a linear model, how do we do it? Here's a simple example. So I've got a bunch of data here like this, and I want to ask, what's the best line to go through that data? Well, clearly this would be a terrible line because it's not near the data. This line here that they've done, this black line, looks like a pretty good line. It looks like it's pretty close to the data. So what we're going to see is how exactly do you draw the line and what criteria do you use, right, to make sure you've got the best line. After we've done linear models, we're going to move to nonlinear models, and we'll show that the techniques are actually fairly similar. Now, what do I mean by nonlinear? Well, one simple way that something could be nonlinear is it could start out straight and then kind of flatten out, or something could start out slow and then get big, or it could sort of do both. It could start out slow and then get big and then flatten out, right? So there's all different shapes a function could take. John von Neumann one time said the set of nonlinear functions is like the set of non-elephants. That he meant that the number of nonlinear functions is enormous. So we'll talk a little bit about how we can use some of the same techniques used for linear models to create nonlinear models. Now, after we do that, we're going to conclude this unit by talking about something I call the big coefficient. So what do I mean? Well, when you have a linear model, right, you have like y equals a1 x1 plus a2 x2. So x1 and x2 are the variables. These are the things that determine the outcome. So we'll talk about, for example, school quality. And so x1 might be what the class size is, and x2 might be how good the teacher is. And so this a1 and a2 are the coefficients, and these coefficients tell how important is the variable. So the bigger the coefficient, the more important the variable. So when I say the big coefficient, what I mean is making policy or making a decision based on which one of these coefficients is biggest. Now that makes a lot of sense. And so what I'm going to do is I'm first going to argue that, better to use the big coefficient than to just sort of do seat of the pants thinking. And we're going to see why that's the case, that linear models are just better, right? We've seen this a little bit before, but we're going to go into more detail. Linear models are better than just sort of thinking off the cuff. But then I'm also going to criticize it a little bit, right? Because I'm going to say that one problem with big coefficient thinking is it only works in the area in which we've got the data. And oftentimes, if we want to make the world a lot better place, we have to shift to an entirely new reality. We've got to shift to a place where there is no data. So I'm going to draw a distinction between what I call the big coefficient and what I'm going to call the new reality, right? Or situations that are just maybe a lot better than what we currently have. All right, so that's a summary of where we're going to go. We're going to start out with categorical models, look at linear models, show how to fit lines to data, right? Then we go to some nonlinear models, and then we'll wrap it all up by talking about this idea of the big coefficient. All right, thank you.